For case 1, we are doing it at Southcoast Medical Company, and our team is Team 4 called Insect. It consists of Natalia, Sergio, Young, Christian, and Devin.
The company's current situation is that Jack O'Neill, the president of manufacturing medical devices at Southcoast Medical, is concerned due to a shift in the past year that has caused their service levels to decrease and their inventories to remain high. An overview of their current problems: they want to improve their service level. So the company's current service level is about 88%. They also want to reduce inventory. Although they had an inventory control system applied last year, their inventories went up recently. And they also want to meet customer demand. Currently, the company is not meeting their demand due to poor production scheduling. Their current service level, you can see here, we calculated each of the service level for each of the products: 5 by 150 millimeter, 11 by 150, 12 by 150. So currently service levels are all below 95%, and we want to improve that to 95. Here's the cost for line 1. There are 9 workers in each line. We are given wages, fringe benefits, overhead, carrying cost, and ordering cost. These are all used in our analysis. We're also given the bill of material. It is important to note that we assume that the production cost includes all the parts needed to make the assembly. For example, the production cost for the 5 by 150 costs $3.20 and includes part 1A, 2A, 3A, and 4A. This is critical for our analysis. Here is the current master production schedule the company has that we will be improving on. Here is the weekly forecasted demand from November 26th to December 31st. Work hours needed to meet weekly demand. We wanted to see the forecasted demand and estimate the production time it would take to meet such demand. As you can see, it seems to be a pattern where we can use to predict that the demands for the rest of the year would have a similar fluctuation. We decided to break down each weekly demand by day. From there, we used the number of parts to determine the amount of time that it would take to produce those parts. Since we only have 360 hours of production, that is to split among 9 employees, that means that each employee will be expected to work a 40-hour week, or 5 days of 8-hour shifts. With these constraints, and wanting to save time on changeover, the following weekly schedule was made. We started with the 5 by 150, then at the end of the day performed a changeover to be ready to begin production on the 11 by 150 on Wednesday. From there, we performed another changeover on Thursday so that we can begin producing 12 by 150 from Thursday to Friday. From week 1 to 2, we decided to save time on changeover and maximize production. We would continue running the 12 by 150 part through Tuesday. Then we would have a changeover on Tuesday and begin production of the 5 by 150 part, and have changeover again on Thursday to begin the 11 by 150 part through Friday. Just like in the previous schedule, whatever part we were producing at the end of the day on Friday will be what we start with on the following Monday. Except now we will have a changeover on Tuesday to begin production of the 12 by 150 parts, that have another changeover on Wednesday to have production on the 5 by 150 part for the rest of the week. Since we assumed a pattern based on the current demand data, this 3-week cycle would continue on until there's a dramatic change in the demand and a new cycle needed to be designed. Now that we know we are going to use the proposed schedule, we had to determine if it was better for the company to have employees work weekly overtime to meet demand or to buy the excess that we need from another vendor. We only are able to outsource the 5 by 150 and 12 by 150 part. That is why in the table above, the cost for the 11 by 150 part is the same. As you can see, it is better if we outsource the 5 by 150 and the 12 by 150. This would mean that we need to run overtime on the weeks that we have not met our demand for the 11 by 150 parts. After coming up with the new schedule, it was found that both outcomes would not be able to meet demand in the 360-hour constraint unless overtime was an option. Assuming overtime is an option, this is a cost of overtime comparing the two schedules. One, the given production schedule, and the other one is the proposed production schedule. You can clearly see that the proposed schedule would save the company about $27,000 compared to the master production schedule the company is currently using. We calculated a new safety stock to include in the MRP. We used this equation, safety stock equals Z times sigma times D times square root of L, which is lead time. After calculating it, you can see that we reduced the safety stock and increasing the service level to 95%.
We also use MRP. MRP ensures that all the parts necessary for production will be available in the warehouse when needed. Some of the factors that we took into consideration while doing the MRP were the lead times, which was given to us in days. This is the amount of days it takes to receive an order for a certain product. We also used the forecasted weekly demands and safety stock, which we calculated based on a 95% service level. This is an example of the first 3 weeks of the MRP that we did for the first part, the 5 by 150 millimeters. As you can see on the left, we have all the lead times for all the parts needed for the production. We have the safety stock that we calculated based on a 95% service level. We have all the quantities and we have all the inventory currently in hand.
These are our 3 recommendations for the company. First, we propose a schedule which meets customer satisfaction and saves the company $270,000 annually. Next, we propose material requirement planning, which meets demands and reduces unnecessary inventory. Finally, we recommend that the company outsource the 5 by 150 and the 12 by 150.